First thing we need to note is that we've got an x squared. So that x squared is telling us that it is a quadratic equation, okay? And if it's a quadratic equation, yeah, hi Jaden, there are two important things that we need to keep in mind. The first is that we want everything on one side and we want it equal to 0. And in this case, it's already like that, so that's great. And then the second thing is we're going to factorize. So those, whenever we see a quadratic equation, we want it to be equal to 0, and we are wanting to factorize. And we've got that x squared and it's quadratic, and we factorize, and we're going to get 2 answers for x. Okay. So let's have a look here. We've got x squared minus 13x plus 36. It's a trinomial. We've spoken about how to do a trinomial using our cross method now. So we're going to have an x here and we're going to have an x there. We need to think what factor pairs of 36 can get us to 13. So if we think we've got 1 and 36, we've got 2 and 18, we've got 3 and 12, we've got 4 and 9, and then we have 6 and 6. So if I'm trying to get to 13, I'm going to care about this pair over here, the 4 and the 9. So I'm going to have 4 and 9, and it needs to be negative 13. So we're going to make both of those negatives, because negative 4 minus 9 is going to give us negative 13. So if you're needing to revise on grade 8 and grade 9 factorization, you absolutely can do that. All of those videos are on the Watobe website, so you can watch all of them whenever you're needing to. All right. So we're just going to pop these in our brackets now. We're going to have x minus 4, and then in our second bracket, x minus 9, and that's going to be equal to 0. And then when we have a quadratic equation like that, we say this bracket is equal to 0 or that bracket is equal to 0. So we're going to say x minus 4 equals 0 or x minus 9 equals 0, which means x is equal to 4 or x is equal to 9. And that is our full answer for this question. Okay, can you let me know how we feel about this type of question? Just give me an idea. Let's give it a scale of 0 to 10 of how you felt about this. And you didn't have to have done it completely right by yourself on your side to give yourself a 10, but if you understand the process of what I spoke about, then give yourself a 10. So let me just get an idea of where you're at. Cool. Awesome. For those of you who have just joined, I'm teacher Jen. I'm going to be with you today. We're going to be working with factorization in different equation situations today. You will have teacher Coco back with you next week, just standing in for today. Okay. Cool, cool, cool. Let's keep going then. So what we're wanting to do now, just move that around, don't know what's doing there, is we are going to start looking at, I'm just going to zoom past that now. We're going to start looking at some of these quadratic equations. So that was sort of just explaining how this is going to go. Now that we've spoken about it and you can see what we've done and you understand that process, I want you to give these ones a try. Okay, so let's not worry about 4 just yet. At the moment, let's just focus on 1 and 2. Okay, so just 1 and 2 that you can see on the left-hand side of your screen. Those are the 2 I want you to focus on. See if I can make it a little bit bigger for you. And we're going to be focusing on this idea that we've just spoken about now. So we have this 0 product law. So when something times something is equal to 0, then one of those things has to be equal to 0. And I know sometimes when we have variables, it makes it a bit confusing, but just think of it as a number. If I had like 5 times 0, then my answer would be 0. If I had 0 times 2, my answer would be 0. So it's just saying that 0 times anything is 0. That's what the 0 product law is telling us. Okay. So it's a quadratic equation. We know that because we've got this x squared chilling over there. We've got this x squared chilling over there. So the first thing we want to do when it's a quadratic equation is we want to move everything to one side and make it equal to 0. That's our first goal. Second thing we want to do is we want to factorize. Okay, so I want you to have a look at these two questions, and I want you to see if you can try and solve them. So think of those first two things. It's a quadratic equation. We know it's quadratic because of the x squared. So when we have an x squared involved, the first thing we want to do is we want to move everything so that it is equal to 0. Second thing we want to do is we want to factorize. Okay, and when we factorize, it could be a highest common factor. It could be difference of two squares. It could be a trinomial. Or it could be, oh, goodness gracious, grouping. All right. So just focus on question 1 and question 2 at the moment. See if you can find some lovely answers for me. And if you're feeling confident, let me know. Okay, so Stacy, I'm liking the numbers that you're using. So I'm liking that 9 and the 5, but I need you to be careful with your signs. Sean, I'm liking what I'm seeing. Emilio, I need you to also just be careful with your signs. And just remember, whenever we have a quadratic equation, we're always going to get two answers. Sometimes that answer is the same as itself. So it could be like x is equal to 2 or x is equal to 2, which I know sounds a bit silly, but it is. But there's always two answers. Okay, I'm seeing some great answers coming in. Let's chat through this. Nice work, guys. So that 45, the negative 45, if we work through our factor pairs, let me get a different color here so I'm not confusing you. Okay, we've got 1 and 45. We've got 3 and 15. We've got 5 and 9. And we can see with that 5 and the 9, we could get a 4. Okay, so we're going to want to minus 5 from 9. So inside here, we're going to have x plus 9x minus 5, and that's going to be equal to 0. Now, if you got to that point over there, I want you to give yourselves a big fat tick. Okay, that's step 1. Step 2 is now we need to say that this bracket equals 0 or that bracket equals 0. So we're going to say x plus 9 is equal to 0, or that's the important thing, x minus 5 is equal to 0. And then this 9 is going to pop over onto the other side, and then 5 is going to pop onto the other side. And when they pop over, then their signs change. So we're going to say, therefore, x is equal to negative 9, or x is equal to 5. Well, I'm so excited you started doing quadratic equations in class today. This is going to be a great revision of that then, and hopefully make your brain super happy. Okay, and then I want you to give yourselves a tick for each one of those answers. So think about this as a mark out of 3. And guys, remember, if there are things that are happening that you are not understanding, it's really important you let me know. So just write it in the chat, send DM, we can chat through it, we can figure out what's going on. Why don't the brackets have the same sign? So there's 2 reasons. First of all, because we're trying to get the 4, but secondly, if this sign here, so the sign just before the constant, if that is a negative, then the signs inside the brackets will be different. And if it's a positive, then the signs will be the same. 3 out of 3, nice job, guys. I sound like one of the announcers on the airplane. Like the air hostess people?
Maybe it means
Okay.
you have a beautiful voice.
Oh, okay. I'll take it. I'll take it. All right, guys, give number 2 a try for me. So we've got 9x squared is equal to 25. It's another quadratic equation because we've got that x squared. So I want you to pass it. Okay, that's how we learn. We can see the x squared. So think about this process. Move everything to one side and make it equal to 0, and then factorize. Move everything to one side and then factorize. Those of you who are feeling like this is nice and easy, you can start on question 4, which should be on the right-hand side of your screen. We will come back to it, but if you're wanting to keep your brain busy while we're working, you're welcome to give it a start. Oh, okay. Well, if you wrote the sum down wrong, then it's not that you really got it wrong. Then it was just a silly mistake. That's okay. Hi, a big welcome. We love our new people. I'm so glad you're understanding. I understand sometimes it can feel confusing. It's especially when we're trying to combine. What's tricky about grade 10 is that we're combining a lot of different mathematical concepts into like one big thing. So this is like bringing in equations and factorizing, and later this becomes graphs. It's all very like, it's a lot, but just try and break things down into steps, like this step, this step. So move everything, make it equal to 0. Second step, factorize. Third step, make this one equal to this equals to this. Mateo, I'm not sure because I'm just a guest. I'm a guest teacher, but I'm sure Teacher Coco has it for later in these equation sections. Okay, let's have a look. We have got 9x squared equals to 25. First goal is we want to move everything onto one side so that it is equal to 0, because if it's equal to 0, we can use the zero product law. Okay. So we're going to say 9x squared minus 25 is equal to 0. Now we're going to go through our factorizing list. We don't have a highest common factor. Can we do difference of 2 squares? Yes, we absolutely can. Okay, we have 2 terms. They are both square numbers and there's a minus sign, so it's a difference. Okay, so we're going to do difference of 2 squares. So we're going to say 3x plus 5, 3x minus 5 is equal to 0. So all we've done there is we've done dots. Okay. Mark-wise so far, I want you to give yourselves a mark for getting it into that standard form, getting it equal to 0. Then I want you to give yourselves a mark for doing a difference of 2 squares. Now that we have these 2 brackets equal to 0, we can say this equals 0 or this equals 0. So we're going to say 3x plus 5 is equal to 0, or 3x minus 5 is equal to 0. If you got to that step there, I'd like you to give yourselves a tick. Now we just have to solve these equations. So we're going to move that 5 over and that negative 5 over. So we're going to say 3x is equal to negative 5 and 3x is equal to positive 5. And now I need that x to be alone. So we're going to divide both sides by 3 so that that goes away. And so x is equal to negative 5 over 3, or x is equal to 5 over 3. And I want you to give yourselves a mark for each of those answers. So looking at this one, thinking of it as mark out of 5. Think about where you got to in this question. And if there are things that are confusing you, just let me know. Just write a question in the chat for me if you're feeling stressed. I'll answer it verbally so you don't need to panic. Nice. Cool. Guys are smashing this. Awesome job. And remember, if you're not getting 5 out of 5, that's 100% fine. That's how we learn. We learn by making mistakes. As long as you understand the process on how we got to these answers, that's what really matters. Okay, I'm going to put both of these up on the board so that you can see them at the same time. I'm wanting you to give question 3 a try, and then there's also question 4. Okay, now we're at this point over here where there's a lot going on. We need to get things to standard form, right? We need everything to be on one side and we need it to be equal to 0, but this is not in standard form because there's a whole bunch going on. So there are different ways you could do question 3, but in general, the easiest thing to do is to just multiply everything out, move it onto the left-hand side and simplify. Generally, that's the easiest thing you can do. So have a look at this x minus 6 squared. Remember that that means that that bracket would be written out twice. We have the minus 24. We're going to move that 1 over. And then I want you to do your FOIL over here. So multiply that out, simplify everything, get yourselves a nice standard answer going on. Now, Maza, how can I help?
Oh, sorry, ma'am. So like, aren't you gonna have to like end up simplifying it again to 6 minus 6?
To x minus 6?
No, not to x, ma'am. I'm saying like, so like, you know how you're gonna multiply out the bracket that's been squared?
Yeah.
Like FOIL. Okay, sure, then that's done. And then like when you simplify it, aren't you gonna have to simplify it again?
You definitely will.
Like get...
So I know. It feels like we're like taking like a step back to go forward. I get it. But in these situations, we have to multiply it out so that we have everything, so that nothing is in brackets anymore. And then we can group our like things together. So then we can like add or subtract our like terms, and then we will have it in standard form.
Yo, ma'am, this is so unnecessary.
I know, it's rude. It is what it is, though.
Ma'am, couldn't you just like skip a step and then like just write minus 6, open bracket minus 6 get, and then do what you need to do? Because like this isn't it. This really isn't it. I am stressed.
There is a way of doing this one in a slightly quicker way, but it's much more confusing. So I think that this is the safer way.
Ma'am, I'm all ears. I'm all ears. I will grip onto it with my life.
I'll put it over here. So another way we could do this question is we've got x minus 6 squared, and then if you move your 1 over, you'll have minus 25 is equal to 0, right?
Yes, ma'am.
Okay. This is one term. This is one term. So there are two terms. They are both squares, and there is a minus sign.
Yes, I hear you.
So how can I factorize that?
Wouldn't you, seeing as 6 and 25 well, like terms with inverted commas, wouldn't you like just like minus or add?
Because this is one thing. We can't they are their own, they're their own people.
Okay. Yeah. Would you multiply it in?
So that's what you're doing on the side over here.
Yo, Anna, guys. Yo.
But so Lihle is saying it in the chat, you could do difference of 2 squares with these two. Because you have two terms, they're both squares, and there's a minus sign. But it's nasty.
Man, let's go back to number 1. I can't.
Yeah. I hear you. Because I was trying to avoid this, guys. Try to make you a little bit happier. So don't panic. Let's have a look at this. I think it looks more stressful than it is. I think once you see it, you'll be like, oh, it's actually not so bad. So all we've done in this first step is we've written out those two brackets. Okay, now we're just going to do our FOIL. So we're going to have x squared minus 6x minus 6x plus 36 minus 24 minus 1 is equal to 0. Yeah, totally. I'll show you how the second way works when people are working on question 4, okay? Now from here, we're going to group our like terms. So we've got an x squared, then we've got minus 6x minus 6x. So those ones are by themselves. And then we've got all of these constants. Okay, so we're going to keep our x squared, minus 6x minus another 6x. That's going to be minus 12x. And then we're going to have plus 36. So we've got plus 36 minus 25, and that is going to give us 11. So we're going to have positive 11, and that's equal to 0. Okay. What we've done now is we have our normal trinomial. We have it in standard form. So all we did over here was we multiplied everything out. So the 36 came from saying negative 6 times negative 6 in my FOIL. That's where that 36 came from. And then once you have it in the standard form over here, now all you need to do is do your trinomial. And that should feel a little bit easier now. Okay, so the reason it's not 36x is if I write this a little bit bigger, so x minus 6, x minus 6. When we do our FOIL, we're saying our first terms, so x times x, that's x squared. Then x times negative 6, that's negative 6x. Negative 6 times x, that's negative 6x. And then negative 6 times negative 6, that would be positive 36. So that's why there's no x involved there. Exactly. Now we're just going to factorize. No problem. So when we factorize, we're going to see we have x minus 11, x minus 1, and that is equal to 0. And then we're just going to follow the little pattern that we know now. So we're going to say x minus 11 equals 0, or x minus 1 equals 0. And so x equals 11, or x equals 1. Exactly. Nothing new. Just factorizing. The only difference about this question is that we're bringing in this extra area here where we first have to multiply something out before we simplify. That's it. That's the only new thing we're bringing out. Yeah, it is better to say therefore. I know some teachers can be quite stressed about that. Okay. You might want to take a screenshot of this answer because I do think it'll help you with the one I'm going to quickly go through. No, it's definitely good. You should keep the therefore there. We're going to quickly have a look at question 4. And then while those of you who are working on question 4 are working on question 4, I'll show you a different way of doing question 3. I'll just write it on the board. So I won't talk about it, so I won't confuse those of you who understand this. Okay, Nomaza, how can I help?
Sorry, ma'am. Couldn't we have just used the quadratic formula?
That is, you can, but why on earth would you want to go through all the hassle of using the quadratic formula?
Ma'am, it just looks easier. I mean, like,
So
we
much
haven't taught
longer. It takes like half a page.
us-
And there's so many opportunities for you to make a mistake. So
Yeah.
it's better to just
Yeah.
factorize than using the quadratic formula.
Yeah. Okay.
Yeah.
Okay.
My goodness. Why on earth would we use the quadratic formula in this situation? You crazy banana. Okay. I'm going to pop this question up here. So I want you to give question 4 a try. So question 4 is the last one we're going to try on stuff like this. And then we're going to do some fraction work. But I want you to think about this in the same way. So do your FOIL over here, multiply those out, move everything on one side and make it equal to 0. And go from there. So Shaden, the thing is that, like Naliswa was saying, it's very easy to make mistakes with the quadratic formula. Very easy to make mistakes, specifically with the pluses and minuses. And putting in the correct values for your A, B, and C. And if you make a mistake in the first row of using the quadratic formula, you will get no marks. Whereas if you make small mistakes doing it this way, and your teacher can try and follow on what you're doing, you would still get some marks. You would get method marks. So we're just trying to help you make sure you get the most marks you can get. Okay, while you're working on question 4, I'm going to show you how to do question 3 a slightly different way. I'm not going to talk through it. I'm just going to write it up on the board for those who are interested. Okay. Please move question 4 to the left. Okay. I'm just going to do the first line, just so you can make sure you're on the right track. And then I'm going to let you carry on working. So I've got 2x minus 15 is equal to x squared minus 6x plus 1x. You can just write x minus 6 minus 6. Oh, sorry, minus x squared. So that's what our first line should look like. If you've gotten to that point, give yourselves a big fat tick. Now think about quadratics. Move everything to one side, make it equal to 0, and then factorize. Oh no, it's okay, Shaden. It's okay. So work with what I've got. If you didn't get those numbers, work with what I've got over here to try and help you out a little bit. It's okay. It happens. It happens to the best of us. Okay. Second step, I'm moving everything to one side, making it equal to 0. 2x. You can also simplify before this step if you wanted to. Minus x squared plus 6x minus x plus 6 plus x squared is equal to 0. Now we've got to be careful. Now we're going to start looking at our like terms. So we've got 2x here, we've got a 6x, and we've got a minus x. We've got a negative 15 and a positive 6. And then we have a negative x squared and a positive x squared. What happens when we have a negative x squared and a positive x squared? What would they do to each other? It's like if I said we have negative 5 plus 5, what's going to happen? Yeah, it would be 0. They'll end up canceling each other out. Exactly. So because of that, we actually don't have an x squared anymore. So we've got 2 plus 6 minus 1. So that's going to give us 7x. And then we've got this minus 15 plus 6. And that's going to give us minus 9 is equal to 0. Okay. Now we have to think really carefully here. Is this a quadratic equation? Is this a quadratic equation? So is 7x minus 9 equal to 0? Is that quadratic? How do we know when something is quadratic? What's our big giveaway for something to be quadratic? Think about like our very first example we did today. What was the thing that told us that this was a quadratic equation? Where's my arrow coming from? Not always when we have 3 terms. Yes, Singa, there we go. When there's an x squared. Okay, that x squared is telling us that it is a quadratic equation. Okay, now if we're looking over here, we don't have an x squared. We just have 7x minus 9. There's no x squared. There's just an x. So this is just a linear equation. It's just a normal equation, like an equation we've been doing since grade 8. But the thing is, because we're doing it in grade 10 and we've been working with quadratic equations, our brain is telling us, oh, well, there must be 2 answers. And so not like if we're in a stressed situation and we're in a test, we'd be like, oh, well, our answers must be a 7 and a 9. But it's actually just a normal linear equation from this point. So all we're going to do, we're just going to have one answer for x. So we're going to say, sorry, guys, I'm going to have to erase this part over here. Otherwise, I'm going to run out of space. We're going to say 7x is equal to 9, which means x is equal to 9 over 7. That's all. Shaden, how can I help?
Okay, ma'am, listen. Before you even started explaining, because I'm under the impression, that's why I didn't get the big factor. I was under the impression that our first line is supposed to have equals to 0, and then after that you carry on.
You can totally
But
do
I
it that way.
didn't-
You could 100% move it all over to one side. The only reason I wouldn't have done it with this one is because sometimes people get confused as to what sign to put in front of those brackets.
Oh, so it's the brackets that's just...
Yeah.
Ish.
That's the
Okay,
only
ma'am.
reason.
I'm still a bit confused, but I am looking into this one. I'm trying to practice. I'm trying to switch it around and see.
Okay. Okay.
Yeah.
And remember, you
But
can always watch the video again.
Yes, if I understood, I would have got that humongous fatigue, ma'am. Humongous. It was gonna be so
Humongous.
huge.
Good.
It was gonna be so huge.
Excellent. That's what I like. Big fat ticks. That's our final answer. That's where we end. So our final answer is just x equals 9 over 7. That's it. You can act like this question never existed. Okay. See. Okay, guys. We are not going to have a brain break today just because we just have too much to get through. I'm so sorry. But please take a screenshot of this and then we're going to jump down into some fractions. Sorry, guys. Take a quick screenshot for me, and then we're going to jump into some fractions. I know, your pro brain. I understand. Okay, cool. Okay.
Okay, ma'am,
Yes.
why is the final answer a fraction and not a whole number?
For this one, why is it 9/7?
Yes, ma'am.
Because when I move my 9 over, I'm left with 7x is equal to 9. And then if I need that x to be alone, I have to divide both sides by 7. And that's why that 7 is going to be divided on the other side.
Oh, okay.
Okay.
Yeah, I'm cool.
Good. Okay. All right. Let's go. Fractions, guys. We love our fractions. We love it. We love it. We love it. Okay. So let's have a look. Let's start with this one. First of all, we don't panic. That is the very first thing. We do not panic. Okay. We look at it. And what we've got is we've got terms everywhere. There's terms up at the top and there's terms at the bottom, and we can't cancel across terms. Okay. So the very first thing we have to do is we have to factorize. Whatever we can factorize, we need to factorize. Okay. So this x plus 1, we can just chuck it in brackets. Doesn't need anything fancy. No, Zudine, give your brain a chance. It only needs to hold on for 20 more minutes. I want you to have a look at this trinomial up here. And we've had quite a bit of practice with trinomials now. So can you please all factorize that trinomial for me? And you don't have to give me the full answer to this question, just the answer to that trinomial. So just the factorized version of that trinomial. If you can put that in the chat for me, that would be great. And then I'll show you what we can do, because then it gets super fun. So all we need to do at the moment is try and factorize that numerator. Keep those 2 brain cells there just for 20 more minutes, and then they tell them they can have a nice long holiday until tomorrow morning. Okay, it's Itumaleng, I like the numbers that you're using. Just be careful with your signs, because remember, we're trying to get -2. There we go. Okay, so we're going to have x minus 3x plus 1. And the reason the 3 needs to be negative is because if we have -3 plus 1, we're going to get that -2. Okay, and all of that is over x plus 1. Oh, goodness, sorry. And that's equal to 0. Okay, cool. The other cool thing about when we factorize with fractions is that normally there's a hint. So like this denominator is giving you a hint. It's telling you that this is going to be somewhere in your numerator, because your teachers are going to want them to cancel out. So this is going to cancel out with that, because they are exactly the same. And so all we are left with is x minus 3 is equal to 0. And I'm going to ask you again, is x minus 3 equal to 0? Is that quadratic or is that linear? Is that quadratic or is it linear? So linear just means one answer. Quadratic means we'll have 2 answers. Beautiful. It is linear. And the reason it is linear is because it is just an x. It is not an x squared. Okay. And because it's linear, we are only going to have one answer. So we're just going to pop that 3 over to the other side and say x is equal to 3. And that would be our final answer. Not so bad, right? Ready to give one a try by yourselves? See how you go. No, yes, you are. I'll try and pop this one up at the same place so that you can see. Don't know why this, see if we can move this. There we go. Okay. Let's have a look at this one. So all of that is going to be equal to 1. I know the bracket's confused. I know. So the first thing I'd like you to do is to multiply out your numerator. So multiply this out. See if you can figure out what's going on over there. And then I'm going to show you something else we can do here. We can do something a bit sneaky on this one. Always with the brackets, I know. Nomaza, what are you going to yell at me now?
Girl, it's not make sure. Yeah. Okay, so like you already answered my one question,
Okay.
which was like if we should multiply it out, but that's fine. So
Okay.
would you turn that 1 into a fraction and then like bring it over to the other side?
You can, but it would probably be easier for the moment to just leave that 1 on that side for now.
Okay.
And then
Okay.
I'll show you a way we can get rid of it to make our life a bit easier.
Sure. Thank you so
Okay.
much.
Okay.
Okay.
Okay. So once we've multiplied out that side, so we get this 3a squared plus 3 plus 10a, and all of that is over 3a plus 1, and that's equal to 1. Okay. Now, the reason this gets a little bit confusing is we've got this 1 chilling over there. It's not equal to 0. We can't easily factorize what's happening at the top on the numerator. So we need to try and think of a way to make this easier for ourselves. Okay. The cool thing with fraction equations is if we have a common denominator, we are allowed to drop the denominator. So let's just write that down. If we have a common denominator, but only in fraction equations, not in normal fraction expressions. Okay, so in fraction equations, if we have a common denominator, then we can drop the denominator. So at the moment, this 1 is over 1. If I wanted it to have a common denominator, so if I wanted it to have a denominator of 3a plus 1, I would need to multiply both of these by 3a plus 1. So all I'm doing there is getting a common denominator. Okay. Now, when I do that, if I follow what I've just said now, I have a common denominator. As soon as I have a common denominator, I'm allowed to drop the denominator. So what I have now, plus 10a, and that is equal to 3a plus 1. And we get to drop that denominator completely because they are the same as each other. Both denominators were 3a plus 1, so we get to ignore them. And now we're just at a place where we have an a squared, which means we've got a quadratic equation happening. So we want to move everything. So that little squared sign over there, that's telling us that this is quadratic. And if it's quadratic, we want to move everything and make it equal to 0. And then we want to factorize. Yes, Nomaza, tell me things.
I am so sorry, ma'am. But I did this in my test where like I got like the exact same denominator for everything. So I would
Yeah.
make things easier. And my teacher marked me down and I was so confused.
Was it in an equation?
Ma'am, it was something similar to this. Like very, very similar to this.
If it's an equation, then I'm not sure why your teacher marked you down. If it was an expression, then I understand.
If it was an expression, why would that
So
be,
like,
ma'am?
because then we have to keep the denominator.
Okay.
We're not allowed to drop the denominator in an expression.
Oh, okay, ma'am. Thank you so much.
Because you know, in maths, we have different rules for everything. It's just how we are. It's just, we're very rude. Okay, I'm going to try and, those of you who are feeling a little bit overwhelmed here, let's try and see what we can do. It's okay, guys. Don't stress. If you're feeling a little bit stressed, that's okay. It's a very normal thing to feel here. Don't want you to panic. We're gonna quickly talk about what we can do here and how we could do this in a slightly different way. Okay. No, I know there's no numbers to cancel. I know. Let's have a look at this in a slightly different way. Okay. Think about it like this. Oh, goodness. I'm just scribbling all over the screen. Yeah, don't be stressed, lovelies. I'm going to write this slightly differently. Okay, I'm going to write this as 3a squared plus 3. Okay. So I'm writing it like that. The only thing that I've done is I've taken out the step of having multiplied out the brackets. Okay, so don't stress. All I've done is I've just done that distribution for you. Let's have a look at this so we can go through it nice and slowly. All right. At the moment, we have a fraction equation. In order for us to make our lives easier, we want to not have a denominator anymore. We don't like fractions. So basically, we want it to not be a fraction anymore. This 1, if it had a denominator, would have a denominator of 1. We want it to have the same denominator as that left-hand side. But what we do to the bottom, we have to do to the top. So we're going to keep this 3a squared plus 3 plus 10a. And all of that is over 3a plus 1. And that is equal to 1 over 1. But we're going to multiply both of those by 3a plus 1 so that we have a common denominator. Okay, so if you have a look at that, 3a plus 1 over 3a plus 1, it's 1. So we're not changing the value of this equation. Okay. Now, 3a plus 1 and 3a plus 1 is our denominator on both sides. Because we have a common denominator, we are allowed to drop it. So we're going to drop that denominator. So what we land up with now is 3a squared plus 3 plus 10a is equal to 3a plus 1. Those are just my numerators. Now, because we have an a squared, that a squared is telling us that this is quadratic. And so we want to move everything onto one side and we want to make it equal to 0. So we're going to have 3a squared plus 3 plus 10a minus 3a minus 1, and that's going to be equal to 0. We want it equal to 0 because it's quadratic. There we go. Okay. Now we're going to start linking our like terms. So we've got this 3a squared over here. We've got a 3 and we've got a negative 1. and then we've got this 10, and we've got this 3. Let's try and write this out. I'm just going to write it next to it over here. Okay, so I have 3a squared, and then a 10 minus 3, that's going to give me 7a, and 3 minus 1, that's going to give me 2, and that is equal to 0. And that is one of our very new quadratic equations. It's one of our new trinomials that we've learned in grade 10, where we have this sneaky coefficient before our square. So we have to think about how to involve that in our little cross. Okay, and when we're in that cross situation, I'm gonna have to do it here on the side because I'm running out of space. So we're gonna have a 3a, and then we're gonna have an a. And now if I put my 2 there, 3a times 2, that's gonna give me a 6a, which is what I'm wanting. And if I have a 1 there, that's gonna give me an a, which is what I'm wanting. So I'm gonna say 3a plus 1 and a plus 2, and that is gonna be equal to 0. Good, guys. I'm glad that you're understanding. That makes me happy. And so then we just say 3a plus 1 is equal to 0, or a plus 2 is equal to 0. So 3a is equal to -1, or a is equal to -2, which means a is equal to -1 over 3, or a is equal to -2. And that's our full answer. So it's like a tough question. It would be worth a lot of marks. It would be worth probably about 6 marks. Komoto, I can try and answer super quickly. How can I help?
Ma'am, how would you
Yep.
know it's always a quadratic equation?
As soon as there's a square, so like x squared, a squared, y squared, z squared, if there's a square in it, it's quadratic.
Okay, thank you, ma'am.
No problem.